Imagine a groundbreaking discovery that could redefine our understanding of the universe. Scientists have stumbled upon a remarkably powerful celestial object that defies classification, and it has the potential to change everything we know about astrophysics. This enigmatic entity, dubbed Punctum, a name derived from the Latin word for point or dot, was identified by a team of astronomers led by Elena Shablavinskaya from the Instituto de Estudios Astrofísicos at Universidad Diego Portales in Chile. Utilizing the Atacama Large Millimeter Submillimeter Array, ALMA, Shablavinskaya made this intriguing find, which is currently only detectable in millimeter radio wavelengths. Punctum is genuinely powerful, especially when you consider it outside the realm of supermassive black holes. Shablavinskaya explained to Space.com, "The scientific community is still grappling with the true nature of this object, but what we do know is that it is compact, possesses a remarkably structured magnetic field, and at its core emits an extraordinary amount of energy. To put its brightness into perspective, Punctum is astonishingly luminous, 10,000 to 100,000 times brighter than typical magnetars, around 100 times more radiant than microquasars, and 10 to 100 times brighter than nearly every known supernova. The only exception in our galaxy is the Crab Nebula, which outshines it among star-related sources, as noted by Shablavinskaya. Located in the active galaxy NGC 4945, which is a mere 11 million light-years away from our Milky Way, Punctum is surprisingly elusive. Despite its proximity, it cannot be observed in optical or X-ray light. It can only be detected through millimeter radio wavelengths. This limitation adds to the mystery surrounding it, especially since the James Webb Space Telescope, JWST, has yet to examine it in near and mid-infrared wavelengths. So, what exactly could Punctum be? Its consistent brightness over multiple observations in 2023 suggests that it is not a transient phenomenon like a flare. Typically, millimeter wave radiation is emitted by cold objects such as young protoplanetary disks or interstellar molecular clouds. However, highly energetic phenomena like quasars and pulsars can also generate radio waves through a process known as synchrotron radiation. This occurs when charged particles travel close to the speed of light, spiraling around magnetic field lines and emitting radio waves. What we do know about Punctum is that its millimeter light is highly polarized, indicating a well-structured magnetic field. Shablavinskaya posits that the emissions we observe from Punctum are likely synchrotron radiation. Generally, compact objects exhibit strong polarization, while larger entities tend to have chaotic magnetic fields that diminish polarization. The team speculates that a magnetar, a type of pulsar with an exceptionally strong magnetic field, could be powering this synchrotron radiation. However, magnetars and regular pulsars are typically much dimmer at millimeter wavelengths than Punctum appears to be. Supernova remnants like the Crab Nebula are known to be bright at millimeter wavelengths, but they are also quite large, approximately 11 light-years across, whereas Punctum is clearly a much smaller, more compact object. At this point, Punctum stands out distinctly. It doesn't fit neatly into any established category, Shablavinskaya remarked. In fact, nothing like this has been observed in previous millimeter surveys, primarily because we lacked the sensitivity and resolution of ALMA until recently. There is a possibility that Punctum could simply be an extreme variant of a familiar object, such as a magnetar in an unusual setting, or a supernova remnant interacting with dense material. However, these remain speculative ideas without concrete evidence. It is entirely plausible that Punctum represents the first of a new class of astrophysical objects that have gone unnoticed until now, thanks to ALMA's unique detection capabilities. Interestingly, Punctum is about 100 times fainter than the active nucleus of NGC 4945, which is energized by a supermassive black hole consuming surrounding matter. Without its exceptionally strong polarization, Punctum might have gone unnoticed in the ALMA data. Future observations with ALMA are expected to provide further insights into the nature of Punctum. The initial observations that led to its discovery were focused on the bright active core of NGC 4945, and it was purely by chance that Punctum was detected within the same field of view. By conducting targeted observations of Punctum, astronomers can achieve much lower noise levels without the interference of the galaxy's bright core, allowing for a more detailed analysis across various frequencies. The JWST could also play a crucial role in unraveling the mystery of Punctum. If it can detect an infrared counterpart, its superior resolution may help clarify whether Punctum's emissions are solely due to synchrotron radiation or if they involve dust or emission lines. As it stands, the situation remains uncertain, and astronomers are left with a genuine enigma that continues to baffle them. In any case, Shablavinskaya concluded, Punctum is a reminder that there is still so much left to discover in the millimeter sky. A paper detailing the discovery of Punctum has been accepted for publication in the journal Astronomy Astrophysics, and a preprint is available on astro.ph. Join our space forums to keep the conversation going about the latest missions, night sky events, and more. If you have any news tips, corrections, or comments, feel free to reach out to us.